In this video, we're going to solve two questions. One is the inverse function question and one is the trapezoidal approximation question. So let's begin with the inverse function question. So let h be the function defined by h of x is equal to 1 over square root of x to the fifth plus 1. And if g is an antiderivative of h and g of 2 is 3. What we're asking to find the value of g of 4. Okay, so let's begin. We know that g is an antiderivative of h, and so we can first starting out by make a relationship between these two. So we know that g of 2 is equal to 3. So 2, 3 in here. If they're antiderivative, then their x and y values are switched. So h has 3, 2. So we know that h of x is equal to h to the fifth plus 1 to the negative 1/2 power. We can start by taking the derivative of h, which will be this. Okay, so that's our h prime, and we are finding g of 4. So thinking about it, there's nothing we are provided in this question anymore. There's no 3, like g of 3, g of 1, g of 4, anything. So there's really not much we can do from here. So think about it in another way. If we cannot do 4 directly, can we divide that into different like small components and add them together? And that's exactly what we're gonna do next, which is divide g of 4 to g of 2 plus 2 to 4, that interval. But to that interval, we don't know anything either. But the good thing is that we know that there must be some amount that we cared about in that interval. So we can starting with that. So g of 2, that's easy. And we can think about that, well, it will become g of 2, not g, but like from 2 to 4 integration of h of x dx. Yep, because from the relationship between g and h, we know that's what we want from here. So we know that g of 2 is 3, and replacing with 1 over square root of h of 5 plus 1, that's our h dx, and using our calculator to do it, and we will get 3 plus 0.152, which is approximately 3.152, and this is our final answer. Okay, so let's move on to the second one. The second one given us a table. And this is a table of values of a continuous function f, and if 4 equal subintervals of 0 to 2 closed interval are used, which of the following is the trapezoidal approximation of integration from 0 to 2 f of x dx? So I will write the questions a little bit out. We're using the trapezoidal approximation. Of 0 to 2 integral of x Okay, so setting up the trapezoidal approximation formula for this. We know it's divided into 4 equal intervals, so 2 minus 0 divided by 4, which will be 1/2. This is the width. Actually, no, the yeah, so if you think about like a curve, if you're using like the trapezoidal approximation, then this will be the height for each one. Yeah, so this is like 1/2 is the height of each trapezoid, because it's like equal intervals, so we don't care about we don't have to care about each trapezoid's area. We can just use the same height for every trapezoid we created. So this will be 0.5, and we divide it by 2 because for each trapezoid the area is base 1 plus base 2 times height and divided by 2. So f of 0 plus 2f of 0.5 plus 2f of 1 plus 2f of 1.5 plus f of 2. So be sure to remember that the first and the last like function, you only do it twice. You only do it once. The others you have to do it twice. Because think about that, if you like adding the bases, the first base and the last base, which is like the very end of the graph, you only add them once, and the others, when you like doing the base 1 plus base 2, you're adding that the kind of like in between, like the middle one, it's twice. You're adding that twice, so you have to account that for which is the reason that you multiply 2 for the middle terms. Okay, so this is what you can show if it's a free response question, but if it's like a multiple choice question, you don't have to do it. You can just directly plug the function f's y values for each and calculate that out. But for this, I will just show you everything clearly. And using a calculator for that, we can get 12. So this is our trapezoidal approximation value for this function. Yep, okay, I think that's it. I hope you learned something from this video. Thank you.